The purpose of this video is to show and demonstrate the significance of glycans in visual arts. In this video, we will discuss what is a glycan, where gum arabic comes from, and provide an explanation of its structure and its applications. A glycan is a generic term that refers to all sugar types and their functions and uses. Examples include carbohydrates, sugars, and saccharides. Monosaccharide is a simple sugar that consists of a single sugar unit, hence the mono prefix. It is the simplest form of a sugar or the most basic unit of a carbohydrate. This unit cannot be decomposed any further. Multiple monosaccharides can be connected together to form a polysaccharide. The prefix poly indicates many units. Glycans are found in many locations. Some of these include animals and plants. From here, they can be extracted and utilized in various materials. Some examples would include paint, fabrics, and medicine. Gum arabic is obtained from acacia trees around the world, but the largest production comes from regions of Africa. Gum arabic is the oldest plant in use by man and its use begun around 5,000 years ago. Gum arabic is a natural plant polysaccharide that is highly branched and water soluble. It is also commonly known as acacia gum. The gum is a dried exudate or sap from the stems of branches of acacia trees. The exudate is harvested by making incisions along the branches or by stripping off pieces of bark. The gum is then collected and cleaned from impurities. Gum arabic is a mixture of polysaccharides and glycoproteins, which gives it properties of a glue and binder. Therefore, it is used as an emulsifier and stabilizer in industrial products. These products include textiles, paints, paper sizing, and pottery glazing. This is the chemical structure of the acacia gum. In the image, you can see polygons interconnected with each other. Each polygon represents a single monosaccharide. There are many different types of monosaccharides. The slide exemplifies arabinose, rhamose, and glucuronic acid. This is referred as chair notation. Chemists also use different shapes with colors to show different monosaccharides. Each monosaccharide is like a building block to build polysaccharides. The slide also mentions beta-1,3 galactan backbone. This refers how the monosaccharides are connected. Monosaccharides can be connected in many ways based on its orientation and location. These connections are referred to as linkages. Beta refers to the orientation of the linkage, and 1,3 refers to the location of the linkage. The structure of acacia gum allows for it to be dissolved in water fairly easily. This is due to the tree-like nature of its structure. This is known as branching. Another factor is its charge. This refers to the energetics of the acacia gum molecule and that it is compatible with the water molecule. The Amphiphalic characteristic refers to the molecule's water-loving and water-hating regions. This is important because the pigment and surface will interact with one of these regions. This allows for the binding to occur. Applications of gum arabic is centered mostly around its binding properties. Gum arabic is commonly used as a binder for watercolor paints due to its previously mentioned high solubility. The paint is made by suspending the pigment color of choice in the gum arabic. The water simply acts as a diluent for the paint that aids in transferring the paint to the paper. The gum arabic aids in binding the pigment to the paper, which increases the luminosity and prevents fading of the pigment. Furthermore, it allows for better control of the paint due to its ability to disperse pigment particles and reduce the evaporation of water. Therefore, it can be worked with for a longer time frame. Gum arabic is also used to aid in binding ceramic glazes. This allows for the glaze to adhere to the pottery before firing. It also increases the fluidity of the glaze mixture and minimizes aggregation of the particles within the mixture. Finally, gum arabic is also used as a binder for the ink and gum bichromate photography. The gum arabic is mixed with ammonium or potassium dichromate and pigment to create a colored photographic emulsion that becomes relatively insoluble in water upon exposure to ultraviolet light. In the final print, the acacia gum permanently binds the pigment onto the paper.